Okay, so we're going to do a proof here. We did one at the end of one of our other videos, and this is just another example. So we're looking at one of the first things I would do is move my end goal down. And I see some opportunities to simplify. First of all, things like sine 2x, that's going to get replaced. I can replace this and this with sine and cosine to try to get it all on the same page. And I think with those two hints, we should probably be able to kind of move forward. Let's see where we get to. So we've got 1 over cosine x minus 1 over sine x, and that's squared. So we're going to multiply by itself. Now we kind of, I'm just thinking, it's fine. We'll just have to deal with it. So we got, might go over and compartmentalize this. I could probably do it in my head, but that's sort of thing's not that useful in a video. So I'm visualizing, multiplying this. So I distribute, right? And I got to get this guy over here. So I got 1 over cosine squared x. I got minus 2 of 1 over sine x cosine x. And then I've got plus 1 over sine squared x. Okay, don't fall for, oops, that's sine squared, not sine x. Don't fall for, the fact that cosine squared and sine squared add up to 1. That's fine, but they're in the denominator. I have to get a common denominator to add them. At this point, I have 3 fractions. All of them have different denominators. So really, I'm going to just bite the bullet and get a common denominator. This needs to be scaled up. So I could rewrite this as an intermediate step. 1 over cosine squared minus 2 over sine x cosine x plus 1 over sine squared x. At this point, I'm going to scale up each of the fractions to get a common denominator. This one needs cosine squared x. This one needs sine squared x. This one needs another sine and another cosine. Okay, so then this becomes sine squared x minus 2 sine x cosine x plus cosine squared x over the common denominator is sine squared cosine squared. And actually that's fine as a finish line because this term adds up to 1 and this term is the definition of sine 2x. So I've got my identity proven. This guy and this guy make 1. Let me use a different color for this guy. Yellow. This term here gives me this. Okay. So another example of working a proof. The key here was fraction operations. Just type it out. Fraction operations were critical. Replacing with just sine and cosine. And as always, putting the bottom and top separate to see where we are headed. So that last part is the choice that I made here. And this is just generally, I think, good proof writing. This got sort of moved to the bottom in order for me to see where I'm starting and where I'm going. I did some compartmentalization over here to make sure that I had it spelled out for myself and I could, have a clear sense of where I was, of what I was doing when I was multiplying out this crazy 1 over cosine, 1 over sine. Might have been easier just to square this out, you know, secant squared, 2 secant cosecant, cosecant squared, but it's going to end up in the same place. And if you're careful, it really doesn't matter. All right. Those proofs can be tricky. Let me know if you have trouble.